Hello there, everybody. Welcome. How's it going? Hey there, Akras. Thank you so much for the sub. Appreciate it, sir. Appreciate it. How you been? Just give you a... Oh, I can't from my phone. Okay, it's different here. But yeah, how's it going, everybody? Welcome. So today... That one. Thank you. So today, we're going to be carrying on with this BVH tree sort of GPU. Yeah, so this sort of GPU BVH where we sort of construct the BVH on the GPU. That's what we're doing. So we kind of got it constructing. We're just trying to work on the visualizer. As you can tell, it's a bit buggy. It's sort of, yeah, we wanted to investigate this problem. So we've got this sort of model, and it did used to animate, but it's went to see the bounding boxes, and it's kind of flickering. So it makes me think the data is different between each frame. But we also had another problem where we were looking into the was looking into the code which was meant to draw the outline of a bounding box, and kind of got a little bit stuck on there, but I think I've figured out how to do it off stream. When to start sooner, I don't like. Start soon. Oh yeah. Yeah, I don't know. I quite like the winter, but I like proper winter where it's like freezing. I I kind of like it when it's like yeah, really cold. But the sort of in between weather is it has to be snowing, for it to be fun. But yeah, I do understand that it gets cold, you have to heat your house up. Yeah. It's just raining and horrible outside. Yeah. Right, so what did we do? Oh, yeah, we changed those to all ones. That's interesting. Right, okay. So basically, let's get up Milton. We should be able to describe exactly what the fix is. It's pretty simple. Where'd my mouse go? Right. So as an array, okay, from this way, and it hits this part of the box and this part of the box. We need to check if the ray where it hits is at an edge. So we was trying to do it with some sort of normal, some surface normal, but it's just kind of the wrong way to go about it. Basically, if you've got a hit on an edge, right? Like, so if you have it on a face, like, sorry, when you hit one face, right? Which means if you make a normal, I was thinking, yeah, I was thinking if you take that normal and then sort of got rid of the component, yeah, it's just really bad way of doing it. But the way I'm thinking about doing it now is like you've got a, when it's an edge, when your position is at the edge of the box on two axes, right? So imagine this is the x-axis and this is the, so this is the x-axis. Very terrible drawing. Right, and then the z-axis goes this way. Right, that's the z. So if the z and the x-axis are on basically a pixel away from the edge of the box, then it's at the edge. That's the way we've got to think about it. So if two or more of the axes are a pixel away from the edge of the box, then we're at the edge of the box, we can color that pixel in. That's as simple as it is, basically. Yeah, also, I'm getting to work on my work by bike, but in winter, use public transport. Oh, yes. Yes. Can imagine. Oh, do you go into the office every day of the week as well? Yeah, the bike is pretty cool way to get into work, but as I said, in winter it's pretty sucky. It's raining, or it's the roads are frozen. Damn. Yeah. Yeah, public transport is not so good. Yeah, it could be the initialization or the deep traversal. It could. Yeah, I'm not sure if it's the initialization though, but we'll definitely look into it. Right. So to do that, to do that solution is pretty easy. Um, so we don't need these normals anymore. Like we just need the front and back in local space, and we just need to basically do like a do like one of these sort of like less than equal scalar, right? For one of these guys, with this and pixel size at front, and then this would give us a boolean times 3, right? So like a boolean vector, right? Then we just need to count it up. So we say sum. Now I don't know if I have a sum bool times 3, and if I don't, this is where we need to add one because maybe I didn't think it would have been useful. I don't think we have one, but we need to add one if so, and that should give us back an integer. So we sum. Oh no, sum element is called. Yeah, we have a sum u32 times 3. Sum elements. Yeah, well we don't have the boolean version. So we should add this into HCC. Be a good little thing. So it'd be a bool, and then we just say, okay, if that is 2 or more, then we're definitely at an edge, right? And it's that simple. So front with back, and that's super elegant. Then this is for the BVH left traversal, and we actually do the right traversal as well. It's just actually that was for the right hand side. Whoops. We just need to copy and paste the code up here to the above one. That's how much we shrunk it by. It's pretty good. Hey there, Sockham. Hey, Sockham. Hey, Eternal Divine Fox. Welcome, welcome. Yeah, not doing bad, not doing bad. Good, thank you. How you doing? How you guys doing? Welcome, welcome. Yeah, BVH hashtag finally hashtag progress. Definitely. We're doing the 3D R&D now. We've had a couple of little things we've been trying out. We're still trying to see if ray tracing spheres is a good idea, basically, if we can get good enough performance. And so I think we should return a uint. That doesn't make any. Oh, okay, yeah. Okay, so if you sum a bool, let's just make it return a u32. I can't bother to be precise about it. Let's make it do like a x dot y plus, sorry, v dot x plus v dot y plus v dot z. And those will all be booleans, but they should implicitly cast into an int. That should be just fine. So we want to do that for the times 2s. So I've got to take this back to, yeah, let's just put it in here, and if it works out well, we'll put it back into the actual compiler. Just a sec. Rightio, see how this goes. Was it Colmac they used? Yeah, use the Colmac keyboard layout. It is the way. Doing pretty good. I'm also making progress on my engine. Sweet. Good to hear. What sort of, have you got a game yet in mind, or are you just making sort of like the engine? Like how far are you through the engine type of thing? Just brought a split keyboard. My second day getting used to it. Colmac DH. I remember using my orthodox layout. I don't know, remember which one it was. Sweet. That's cool. Right, we're getting some dots. That's about it. Let's figure out why this is. We're getting some dots though. greater than or equal to 2. Oh wait, front local space. We still need to do the subtraction between the sub f32 times 3 with the half dims. Half dims like that. That's the reason why. So that'll tell us how far away from the edge. Right. Fingers crossed we get a box. Yes. No. What is going on here? See, something's up. There's something else that's up. I think we're getting a good box now. It's just stretching along the wait, can I go up? How do I go up? There's my keys. It stretches along the we're doing something around the center. There's something going on. Can't quite put my finger on it. But when it's all in the middle, it's interesting. Yeah, just the way I programmed it to be flickering and all that. Yeah. Well, working on 3D rendering, the 2D rendering is done more or less. Sweet. Good, good, good. Yeah, okay, so you got a weird bug doing 3D as well. Excellent. It's the way it is. 3D graphics development. Endless bugs. This thing does move, I promise, but does wobble. But we've turned it off because we want to sort of just actually see it or debug what's going on with this BVH. So we can actually get it to do more. We're stopping it. Yeah, there's this bug in the HTC compiler, but I fixed it now. We should really go and grab that in a minute. But yeah, so you can't do this double because it produces another basic block and messes things up. But if we remove this, we should be able to see it for the full tree. Yeah, so we're seeing it sort of go. It's flickering like crazy though. But yeah, let's fix up the rendering and then we'll deal with the flickering part. Sorry, yeah, the rendering of the actual box. We're doing something dodgy with the like it's happening around the as soon as the main box. Oh yeah, okay. Maybe. Oh, is it the main box? Left. Right. So basically what we have is we have a BVH where we've got the root node and then which is we basically ignore that one. We just assume we always hit it. So we skip it. So it should only be rendering the next 2 boxes, which shouldn't be inside of each other at all, right? So when we're rendering less than 3, we should be rendering index 1 and 2, right? So what we're seeing is we're seeing this box on the outside, and then we're seeing another box which is kind of like inside it, and it flickers with another box. So something is really up there. So should we just look at the data? Like, let's open up RenderDoc because I think or maybe we should read the shader from top to bottom and then look at the data. I think we should read the shader first. Hey, not so red. How's it going? Yeah, not doing bad, man. Not doing bad. Yeah, pretty good, thank you. How about you? How's it going with you? Have you been having a good weekend? There's like clipping issues, fair play. Yeah, but where is it clipping? That's the question. Bum bum bum. Awesome, good to hear. Good to hear. How long did it take me to use the call Mac? I'm not sure. I also switched Vim layouts as well. Like I had a custom Vim. Well, I have a custom Vim thing. I basically took someone else's from the internet and then changed it like crazy. Um, yeah. So, I think it was like a week or 2 weeks, something like that. Yeah, it's it's definitely nicer to program in. The only issue with it is when you have to constantly remap for games that don't support scan codes for their keyboard layout controls. But also, um, but it's pretty good for most standard applications though. Yeah, I manually did it because if you try and use like okay, the standard Vim layout is actually pretty. It's like a D. If you just give it like a school rating, it's like a D. Like it's just good enough for people to actually use. What is really good is the modal editing. That's what Vim is really good at. But just in terms of like the way everything's laid out, it's actually really bad. But it's not so bad that it stops people using it. So when you actually like change keyboard layouts and it's even worse, you then are just like, right, I've got to just redesign the whole thing. You can just redesign it to something that's way better than Vim. Like, no, we're talking about the Cormac keyboard layout. Then when you switch to the Cormac keyboard layout, yeah, let's use escape. Oh, that's in firmware. That's cool. That's using Qt. Nice. Yeah, that's cool. You can like switch between it, right? Right. Let's read over this and see what we can digest from it. So we have our BVH. It's like a binary heap. Um, so we only should be rendering the first two nodes, right? We start this one off at 1. Um, okay. Closest hit depth infinity. Closest hit max. Yeah, level max is cool. Um, yeah, it's all pretty good, I think. There's some stack that we can use again. So we get the left BVH node and the right one is just 1 plus that. That makes sense. So we process the left node. We get its access line bounding box min, get its max. We calculate T0, T1, so the hit points along the ray. And then we calculate essentially T min, T max. Yes, the hit positions along the ray. So if we're a hit, we say we've hit the left hand side. Yeah, so if we hit the box, we get the size of a pixel at front and back. Right, the front and back could be wrong, thinking about it. because your ray can come from different directions. I think this is part of the problem. Like, when I said front and back, how does that work out? I guess, yeah, pixel at min, pixel at max. But then we calculate the front and back at the same sort of way using the Tmin and Tmax. Okay, that's fine then. That's not a problem. So we calculate where we've hit the front and back, translate it into local space in absolute coordinates. Or, well, okay, it's sine norm and then we absolute it. Well, sorry, it's in... Well, yes, it's in... Yeah, it's in the local space and then we absolute it. Yeah, it's not normalized. And then we do this new thing which we did today, where we just say, okay, if we've hit the edge, yeah, we've hit the edge, which is two of the dimensions are less than pixel size away from the edge, then it means we've hit an edge, right? And we should draw it. Okay, and then we just do the right hand side as well, which is the same. Basically the same code. Remapping escape to caps lock. I don't know, escape's kind of fine. Yeah, I think the standard default of Colmac is backspace. You can use the backspace for caps lock as well. But yeah, like a caps lock is kind of pointless. Like if you have like a text editor, because you can basically just like highlight and then just uppercase it. So it's kind of pointless. Oh, rapidly press in JK. Okay. Yeah, even if you need like IntelliSense to do like capital letter stuff, usually you would sort of like start typing something. Yeah, in capitals, and it will just display it, and you can just type the rest in lowercase. So you don't really need the caps lock there either, you know. So it's pretty good. Yeah, I think we went over this. I think we went over this last stream, but yes, if you've hit the left, yeah. So it says if you've hit the left hand side BVH, and then we also check if you hit the right hand side BVH as well. And if it has any children. If the right hand side has any children, then we back it up, and we'll come back to it later. Right. Come back to it later. Yeah, then this one is saying if you haven't hit the left at all and you've only hit the right, then we just say the next one is the child of the right hand side node. Hey Jero Mimus. Hey, sorry, I forgot at the beginning. Yeah, basically. Any progress on the BVH stuff? Yeah, so we're just trying to render the one is flickering. Two, our BVH, like we got the root node, we got the two children nodes. We skip the root node because it's like, duh, we're gonna hit the world, right? We're gonna hit the world, so we just save that, and we traverse down the tree and test two nodes at a time, right? Yeah, we just do 2 nodes at a time. If we hit the left-hand side and we hit the right-hand side, we'll traverse down the left-hand side and check those children, but we'll back this guy up on a stack and we'll come back to it later. And then we just repeat that. But if we only hit the left or only hit the right, we sort of just go down to those children, right, and check those. So we check them in pairs. That's why we kind of skip the first one as well. There's something weird going on where it's kind of flickering, and also I'm only displaying the first 2 boxes because of debugging. I've said, hey, only run while the next one we're going to process is less than 3. So you've got 0, 1, and 2, and we skip 0, and we start on 1 and 2, right? So we should only be seeing 2 boxes. We see 2 boxes, but should the boxes be inside of each other? Maybe this should be. Yeah, the boxes can overlap. That is fine. That is fine. But they're flickering. I think that's part of the problem. I was just going to study the data, but I think it's fine. They're fine to be inside, actually. Go for Jeremy. Got it. Welcome, Jeremy. That's fine. Right. Yeah, so this code is fine, right? And then if we hit the left, we see if we've hit the right and it has a child, right? Because we only really want to traverse down if it has a child. It's going to traverse down the left. Yeah, that's fine. That's fine. Because if this goes outside of BVH nodes count, it's going to end anyway. So if we haven't hit the left or the right, we just set it to the end one basically. And then if we've outside of the array, we've reached the bottom of the tree. We see if we've got any left on the previous hit stack on the right hand side, and we basically just go and fetch those guys out. And yeah, basically just fetch those guys out. And then if we haven't got anything left, we say is running false, and we just end. So yeah, it's pretty difficult to debug, but I think it should be pretty easy to see, like, so if you see that it's flickering, right, it means something's up with the data. So what we're going to do is open up in see, I'm not sure how people do graphics programming for this program, but they probably like just didn't do it as well. So if we open up in here, we can literally just like capture it for the first so many frames. Just capture it for like 4 frames. And so we'll see it flicker, right? Just capturing 4 frames. Maybe I shouldn't have captured 4. Maybe 3 or 2 or 3 would have been fine. Doesn't usually take this long, mind you. But we should be able to see the data in the buffer and just see how it's changed. There we go. That's way too long. But we should see the pictures, right? We have a box, we don't have a box, we have a box, we have a box. So these two will pull up and we'll just see what the data looks like. So if we go into so which one is our shader again? It's this one that builds the BVH. So we should be able to see the data from there. We do CS, it's this 251 because I remember from last time. We're going to open it up here. Then we use this BVH node 1, which I made earlier, to analyze the data, right? So we've got this one buffer contents here. Then we need to load this one up in another instance because you can't have 2 instances loaded at the same time. So we do the same thing again. Go down to that one, which is our shader, which makes the BVH. We can go over here, click on this guy, click on this format. Now we can see the data side by side and see how much it differs. So what we have is we have 0, 1, and 2, right? 0, 1, 2. So we skip 0 and we just look at 1 and 2. So this is the one where the box was showing up, the second box was showing up. This is one where the second box was not showing up, right? So it should be in maybe the 2 box. I'm not sure. But we just want to verify if the numbers are the same. Export to CSV. Oh yeah. Oh no. Right, so looking at these, the numbers we're getting, they seem to be the same. Right, so the same for the min. Let's go over to the max. 25, yep. Looking good and looking good, right? So the data seems the same, but if we go and see the textures, how do I view this again? We do a custom render, so it thinks it's a different format. Problem is, it's a really big number. I don't know. Yeah, it would be very close to the screen, wouldn't it? Yeah, these must be a very small number. But specifically for the second one. But yeah, I'm trying to see if the data will show up, but it's not. Yeah, so we're viewing these guys. We can't really view the, oh, can we view the, oh, as a copy image. There we go. Oh yeah. Oh no, but then it's showing up here, damn it. What? Right, we should have looked at that first. It's showing up. No, 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 get over there, please. We was looking at that guy. Something's fishy. What? Okay, let's close the other window. View the data again. Oh, it shows up now. If I change it... No, that's weird. It's glitchy even in RenderDoc. Maybe I'm seeing... I think what RenderDoc does is sort of like runs the code. So you might... Like it runs the code to get this output again. I don't think it just stores the textures out. So I'm not sure what's going on actually. Yeah, because every single time we change it, it changes. It's not good. Right. So let's just investigate the code and see what's going on. That was not helpful, unfortunately. Okay. So let's just quickly double check and make sure we've got all of our sync code correct. Because it could just be a sync code problem. I swear we checked this last stream, but I just want to double check. So we've got this sort of reset. So we're going to write only to this node buffer. Yep. We calculate the bounds where we start from the leaf nodes and we just traverse up. We should check that code again and make sure there's because we do some weird atomic thing, so we should really look into that. But we read only from the spheres and we read right to the nodes. That's fine. So that's the sphere ray tracer. We're not using the BVH yet. We're still using the tile system, screen tiles. Here's our BVH viewer. We are reading from the BVH nodes, and that's about it. We're only reading 2 of them. Right, so last stream I did say I wanted to test out what happens if we just had a hard-coded BVH, right? And if we just hard-coded it, and I think I removed the code, so let's just double check quick. So we just hard-code 3 of them, BVH. Yeah, I did kind of remove it, but it's fine. So we'll just go to the spheres, we'll grab this. So this is where we're doing the spheres thing. We'll just quickly, whack one of these in. BVH node, BVH nodes, BVH node, BVH. And voila. So we're literally just going to write 3 nodes. Right, we'll just view them in the world. So we're just going to go, oh, okay. So it's .min.max. So min. So we're going to skip this one. So technically it doesn't have to be correct, but let's just make sure it's correct, I guess. Let's just say it's at 10. I think let's just make them all even. And make them all even, then yeah, so we'll say 10 to about, I don't know, 240. Where's that gonna land? Wait, how wide is this thing? Oh yeah, we probably want the X and Y to be, yeah, what's the sort of, where's this offset at? Resolution of 20 across, isn't it? Let's just do it nice and small. And we'll just do in-betweens of that. And we'll see how if that ends up. Yeah, so this one needs to actually be converted into a bits to bits from. So it actually needs to be converted into a U32 times 3 because you use atomics on it. And you can't use atomics on floats in shaders. So we'll have 2 children nodes, and it's all implicit. So this will be the left-hand side, and this will be the right-hand side down here. So we'll just make this one like, this one could be 10 to 14, right? So we have a bit of space, and this one will be 16 to 20, right? So now that we've done that, what we should do is do sort of BVH, that BVH count. We should comment these out and just say we got 3. And then what we're going to do is we're going to find, yeah, just say we've got 3 of them. Let's just view it, right? And away we go. Yeah, so the coloring is like you are right. The coloring is used to distinguish something, and that is what level it is on. So we're getting a brown color right now, just because it's a random hue. We're doing like a random hue, and it's just landed on basically a brown. Well, yeah. So basically, this level, each node on this level gets a color. Each node on that, I think, is each pair? Or is it level? No, I think it's each level. Yeah, each level. So these all get a color and so on and so forth in the BVH viewer, basically. So we're only seeing the first level right now. And that's what we're debugging. And it's flickering, so trying to find out why it's flickering. Yeah. Right. If the GPU crashes, I'll be right back, but it shouldn't crash. Shouldn't. Alright. GPU didn't crash, that was CPU. Right, we tried to upload way too many BVHs. We only want to write 3 of them. 3 nodes. Right, let's go. Sync that. Okay, so we've seen them up here. And they're not flickering. Interesting. So let's move them down a bit. I don't know why they're... So maybe we should go from negative... but maybe when we start doing negatives. It's interesting. So why don't we start from 0 and let's just work our way to 10. So we'll go 0, 4, 6 to 10. Yeah? So we try that. It's all in my face. So that's on 0. So let's up them by 1. All of them by 1. Okay. So as you saw, when we got it on 0, exactly on 0, I think the ray... No, it can't be. Can't be the problem. But yeah, so let's bring these numbers down a bit. So let's say... Let's do like 5 is the new max now. We go 1 to 2. And 3 to 5. Something like that. Why is it all the way up there? Oh, it's because the Z range, damn it. Yeah, we should yeah, I think we should code these a little bit more manually, unfortunately. So we'll just do like, let's do 1, 1. Now let's put it away from the camera a bit. Right, so let's do maybe, I don't know. Let's do 50. Right. So then we'll say, okay, we'll do maybe 10 or 20 is our max, right? 20, 50. So it's kind of going to make it, right, we'll do 1 up to about 70, so it's got 20 depth. So let's put these in. Hey there, Sully. Can you move though? No flickering. Yeah, I'm not sure about KD tree. I think the BVH is better. Although I'm still pretty new to this myself. So you've got 1, 1. So this is a child of it, right? So we'll do this one up to 10. And we'll do this one up to from 11 to 20, right? Okay, let's try this out. Right. So not seeing any flickering now with these boxes, and these are hard coded. We're seeing 2 boxes and not a third one. Right, the third one encompasses, and that looks correct to me. Right. It's sort of square. Like, yeah, they seem correct, and they're not flickering. Right. So it could be something with the atomics in the shader, I reckon. Yeah, that's interesting. So, but let's monkey around still and see how this could, like, when we did zeros, when they started min on 0, oh, that's still fine, is it? Good. So the reason why it wasn't fine earlier, because it was right in front of the camera, perhaps. Yeah, it was at 0, 0, 0. So it was on the camera. I guess I didn't have like a near clip or something. Right. So we're able to draw 2 levels of boxes. Should we try another layer? Or, yeah, let's try another layer, because I had, when we debugged it earlier, we was only seeing the right hand side being taken, right? So I want to see why that is, right? So we do another 2 lots of 2. And we go, okay, up you by 2, please. And up you by 4. Now we just got to fit these in. So this one is the left. These 2 are on the left hand side of 1. Is that right? Yeah, so root, left, right. Then these are on the left hand side of 1. These be on the right hand side of 2. Oh, sorry, these are the children of 2, which is the right hand side. Right. So this one has to be in between 10 and, or 0 and 10. So we can say 0 to 5, 5, go to 10, 10, 5. Well, let's make them off by 1. We've got a bit of spacing. 6, 6. These guys are going to be from 11. So 11, 11 to 20. Just do the same sort of thing. 16, 16. Right, so let's upload 6 of those boys. Where's that? 7 now? Yeah, it's 7. 7 of those boys. I think that's correct. Yep. So we need to make sure we actually say we've got 7 nodes now to view. Boom. In the shaders, we need to uncap it here, so we can actually view more than many layers. Who am I betting on for World War III? I'm not sure you mean exactly. Right, so let's just... Right, so GPU could crash. If so, I'll be right back, but it shouldn't crash, right? Okay, we're good. So we've got our boxes now. Right, so we've got a... This is our... So from our root node, we've got a left, we've got a right. Then inside the left-hand side, we've got another left and a right. Then inside our right, we've got a left and a write. Okay, those seem to be viewing okay, right? We could keep going deeper. But I think that's okay. Should we move the boxes around though? Let's move the boxes around and just double check. We'll move them over to the left hand side. Or we'll make them span the left and the right. I'm a bit confused. Won't we get in bugs? The way that we're sort of stretching and that. It could be the way it's being generated on the GPU with the mins and maxes maybe. So we had a problem where it was sort of stretching along an axis and not sort of going into... It was stretching along the halfway point and it wasn't allowing it to go like anywhere. Like the boxes. It was weird. What was happening again? I was moving it around and it would get stuck on this halfway point between the halfway of the screen along the X or Y axis. So if we were to move these up by 2, say, these zeros, is it stuck on the 0? Right, it's definitely made it smaller. Right, we can see that. So it's not getting stuck. So that means that the code that introduces it getting stuck is not in the BVH ray tracer. It's actually when we generate them on the GPU, somehow. So we'll look into that as well. You don't need a KD tree. Do you think KD is searching for the nearest point on the BVH boxes? Oh. What about the case where you don't have a pair as leaves? That's a good point. No, you always have a pair. You always have a pair. Yeah. Always. Because if I was to introduce another leaf node here, it doesn't make any sense. Why would one point to one more? It would never do that. Because that is the leaf node. Right. Yeah. Because data is only stored at the leaf nodes. So if you just introduce one more leaf node, it's not... Like there's still only 4 leaf nodes, right? When you add one more, it splits it. And this one goes, and then it moves down to here, right? That's why we never have a single child. Okay, I think that's fine. I think that's a good enough test. So let's revert back to where we were. So what we've figured out is that the code, that the BVH traversal code is probably fine. The issue we have the interesting thing is the shader ran. Yeah, I could have got GPU crash there, I was lucky. I need to remove this. Just run the reset and run the count command. So it's something to do with this code here, and luckily it's very small in comparison. So it should be a lot easier. Hey Ozpil. A CNC plus JSON library? Not really. You can just make your own, right? See, this is the problem we've had. It's like very weird. Very weird. So could it be that the min and max is not min max anymore? You know, it's like the max is min and min is max, right? It's the other way around. Could that be what's causing it? Because only one hand side ever, you know, when you go in there, very weird. Then they flicker. All right. Very fishy. So I was doing a thing where I could check that. I was basically doing a thing where I said, okay, well, if basically when do less than equal f30 times 3, ABB min. So if the max is less than the min, right? Not really equal, we want to say less than, right? If that is true, so I want to say any, all, there we go. If that is true, we're going to do GPU print, GPU h print f, and then we'll just say max is less than min. So I did this test before, and I have to put a thing out because it expects at least one. I got a bug, but anyway. So we should see some prints there, hopefully. Let's try that out. I'm trying to use rapid JSON, but it gets stack false. See, JSON isn't too bad to just parse yourself, right? Like, it's pretty simple to pattern roll. And also, if you only need to support JSON 5, well, yeah, I don't know. Maybe JSON 5 is not easier. It's a little, yeah, it's pretty simple. Pretty basic. Right, we're not seeing any GPU printouts, which means the mins and maxes are fine, right? And if we turn that the other way around, right, just to show that this thing does do something, we're seeing a bunch of prints, right? So all of the, you know, this is correct, right? The data seems oh my days. So let's take a look at the BVH generation code. So the BVH reset, which runs, we'll start, it's very simple code. So we should actually be able to just look at this, find out the problem, hopefully. So BVH reset, we simply just go over all the BVH nodes and reset them. If the node index is out of bounds, so we do 32 at a time, and we set them to infinity, just because infinity is a value, not because we min or max with it. So it doesn't have to be negative infinity, and you'll see that in this calc bounds thing. So we'll go to when we dispatch these guys, we put the nodes count into there to check if we're out of bounds. We've got the resource here. We say we're going to write to it, right? We just write into it. We dispatch on that BVH reset, and we launch this many groups, right? The you know, a rounded up divide of nodes count, and yep, it's fine. So we just reset all that, and jobs are good. So that is fine. The next thing is this guy. This one, this is how we calculate the bounds. We start at the leaf nodes, and each thread gets a leaf node. And then, so we start, each thread gets a leaf node, and then it calculates the bounds around its two spheres, right? And A, B, B. And then they both go up the tree, and one of them is gonna check, yeah, they're both gonna check if another node has been by here yet, and if it hasn't been by there yet, we'll simply skip Yeah. We'll simply terminate this thread. So this one goes up here and it goes, oh, has the right hand side been passed here yet? No, it hasn't. It will terminate itself. The right hand side goes up and be like, has the left been here? And it's like, yes, it has. So this one will go like, okay, I'll get the size of the left and the right and sort of calculate a min max and then store that in the parent node. And that will repeat all the way up the tree, basically. Right. So it's quite basic. So you get your leaf node index, we dispatch over all leaf nodes, we get the nodes buffer, we get the spheres, so we can calculate the original banding box, get all the spheres in there, boom. Hey there, Jamega, how you doing? Welcome back. Right now, I just want to get Flutter text input working. It requires JSON. Right, fair play. Hey, Crimson Mania, welcome. How you guys doing? So the number of dispatch groups we have is this divided by that. Yeah, the number of leaf nodes divided around up to 32 because we're launching 32s, yeah? Boom. So read writes the node buffer, read only to the spheres, right? Launch the count bounds, and we launch this many groups. Boom. So, pretty good so far. So we simply just get the leaf node index by using this, right? Pretty basic. Then we calculate, like this is all fine, I've checked it, right? We calculate the base, the leaf base node index. So right now this is a leaf node index, meaning this is 0, this is 1, this is 2, this is 3. Now I need to calculate it as a node index within the whole tree. So we get the base index, and then basically from the base index is that plus whatever the node index, the leaf node index is, right? So get the base, that's fine, that's the way you work it out. We've checked that a few times. It used to be wrong, but it's no longer wrong. It could be with the atomic code down below. We're just going over the shader. Then we calculate the node index by doing the addition. If we're out of bounds, we return. We get the base sphere index because if we fit 2 spheres per leaf node. And then we calculate the spheres. See, part of me is thinking we can get rid of this check by just padding the buffer with spheres, and you have basically these spheres that don't really have any substance to them, and you could basically just get rid of the branch. Probably not a big issue, but it's, if we add more, it will be a bit of a weird issue. So we calculate the min max. So we're just doing like subtract the radius, add the radius. There's the original min and max. Calculate the new min. Get the new sphere in there. Jobs again, right? Good. Doing something different now, working on my file system lib, mainly the virtual file system. Pretty cool. So that includes virtual mounts, path macros, pseudo file systems, like zip files, etc. Pretty sweet. Sounds cool. Like, it's definitely one of those things where, like it's definitely like one of those things where it's definitely a really cool thing to have, and then like, but you definitely don't absolutely need it. But it's definitely a fun engineering solution. Like, yeah, the one problem that I think it solves the best though is the assets, isn't it? Where you sort of like have the assets that could be on outside of a zip file, but when you ship it, they're inside of like a zip file, and you can sort of mount the zip file. Yeah, it's pretty cool. I like it. It makes me want to do one, Joe Omega. Yeah, definitely one of those fun engineering things. You can have like custom variables and stuff. Are you doing the custom variables as well? How's it going? Has the heap been resolved? Heap. Yeah, we did the binary heap. We're generating a binary heap, but something's wrong. It's like blinking like crazy. Oh. What happened there? Oh, okay. That's me. That's the print code. Don't worry, that print code was wrong. I was just flipped it the wrong way. So it's flickering like crazy, and it's only drawing really one hand side, kind of. It's really weird. Also, it's really going close to the camera. That's something Akraz picked up on. It's going close to the camera, and it's not really letting it go past this midpoint as well. Really weird stuff. So we'll keep an eye on why this is happening. So I think it's something to do with the min maxes. It's getting caught. Oh my days, get out of there. Yeah, it's like it's getting caught on. So you have like your sort of the halfway point in the camera, even like, so it'd be like that, and then you move the box over here, and it will just basically stretch by doing the mins and maxes, and it does that even on the Z as well. So it won't get past the camera, where the camera sits on 0, 0. So that's definitely probably what's causing the flickering actually, is that, and not probably a data race problem. It could be the min max. Map points can also have multiple entries. Since you have since you can have mods overwrite stuff. Ah. Right. So you can basically apply stuff over other stuff. Okay. That's pretty cool. Yeah, I think this system and like a job, multi-threaded job system, is one of those things where I want to spend some time and engineer it, but I don't know what problems it's actually going to solve for the game. This one, you know what I mean? They seem like a lot of fun. Mainly because I've not written one. Well, I think I've written like a job system before, but I want to write a better one. Right. That sort of stuff. There's so many good things to program in games. You can also do path like macros or path for the macro, which can go into stuff like. Oh, yeah. Nice. Async IO for native stuff. Virtual file system, I'll give you something to figure out. Ah. Awesome. Right, so I think the mins and max is working fine for the spheres. It's just when we go into this silly. I don't think it's my bits from thing because that's just built into the compiler. It's just it's a reinterpret cast. This is not the way it works in the shape. Like this is so CPU compatible. It never runs this code. It's done in the compiler. Right. So, we got our node index. We store it in our leaf node. We have to convert it into U32 because we use the min. It's really dodgy. It has to be U32 times 3, but technically it's a float 32 times 3. Like but we just sort of reinterpret cast it into that. Because we need to use an atomic operation on it, right? Okay. So as I said before, we get the parent index, we look at the parent's min.x and we exchange, atomic exchange. We put an NaN in there, right? So when we get the value back, it's going to be infinity, right? But then we check if it's NaN, because the second time it gets exchanged, then you'll get an NaN back out, right? So when you get an NaN, we could do another value other than an NaN, but I'm sure NaN is... What is it in SPIR-V? Because I can check this file for it. Op is NaN. Excellent. So let's just quickly double check that actually shows up in the binary. If it doesn't, that's probably the issue, but we're going to build... Okay, whatever. SPIR-V dis... Yeah, we're going to look for is NaN. Right, we got one. We've only got one of these in the whole code base or for shaders. It's showing up. Means that's fine. So, okay, that is not the problem. So, yeah, so then because it's a binary tree, we can't, with the, we know the left and right. We can now guarantee the left and right not being touched by any other threads, right? So we take our node index, our whole node index, and we XOR it with 1. So if it's the left-hand side, it's odd. If it's the right-hand side, it's even. And that makes sense, right? Because as you go down the tree, this is 0, 1, 2, 3, 4, 5, 6. So if you have 5 and XOR it with 1, you get 6. Wait, is that right? No, you get 4, isn't it? This could be the problem. This could be the problem. Yeah, because 2 you'd get 3. This is part of the reason why I stream it, so I can literally spell it out every time, and then I can think of the problem piece by piece. Yeah, because 0 will get you... Okay, so what we need to do is up it by 1, XOR it, negate it by 1. Something like that. Sorry, take away 1. Yeah, so take away 1, XOR... Is there a better way, though? Then add 1. Or we XOR it, then take away 1. Is that right? So if you say 1 XOR, that gets you 0, doesn't it? Then 2 it will get you 3. Yeah, so this is what's happening. This is the problem. Take away 1, then we add 1 again. So you want to get your sort of sibling node. Zero, 1, 0, 0, XOR... Three and 4. Oh, so you're saying 3 and 4. Interesting. So what you're saying is 3 XOR 4 equals 2. We don't want that though, right? We want 3. You basically want to figure out, if you have 3, how do I get 4? If you have 4, how do I get 3? I think the best way to do it is sibling sibling node index. I'm not sure what you're saying. We're gonna check out. Okay, awesome, Jamaica. See you later. Good to see you, man. Right. So if we have 2, we take away 1, get 1. We XOR it, get 2, then take away 1. Right, we land on 1. If we have 1, we take away 1, 0. XOR, get 1. Oh wait, it was an add 1. Shoot. Alright, let's restart this. 2, take away 1. XOR, get 2. Add 1, 3. That's not what we want. So these sort of adds and minus, they're not, that's not good, is it? Yeah, libraries are always bad. Pretty much. Very, very rarely is there a good library. Plus, JSON is so damn simple. You just parse yourself anyway. Okay, so how do we... I could have swore we just did... Right. What? No, okay. Okay, the code is correct. I was just in the example wrong. You got 2, take away 1, XOR it with 1, you get 0. Then you add 1. Boom. That makes sense. You got 1, take away 1, XOR it, you get 1, add 1, you get 2. There we go. It works fine. It works fine. So this is fine. Right? So we'll put a comment here and just say, you know, we'll put a comment and say left nodes are odd, right nodes are even. With that alone, they should be able to figure out the rest, right? So you get your sibling node index, we can wham it in there, right? Okay, so that is probably the issue that's causing everything. That's the whole reason why the min and max was all wrong. Against, you know, so it should, right. So again, we've changed something vital. Stream could crash, but it probably won't. Let's go. Okay, so what we're seeing is we're seeing all the boxes, right? It's pretty cool, but we're seeing this damn big box, which is stretched across the whole screen up to the top, which is super weird. But it's brown, which means that it's probably the first, it's probably the left or the right node, basically. Yeah. So, if we simply just, we used to have a thing, oh my days, get to the bottom. We used to have a thing here where we can't do and because there's a HTC bug which I have fixed. I just got to bring the new compiler in. Yeah, so let's limit it to the first 3 nodes, which is actually the first 2 nodes because we start on the left-hand side and we skip the root. So let's see if that's still there. Right, so obviously it's still there. Do we see 2 boxes or do we just see 1? Right, as you see, oh, it's going off into the infinity. Woo! And then it's going up as well. So there's something fishy with the final sort of right node or left node. I'm not quite sure. Now, so I guess let's keep reading the code and seeing if there's any other issue. Why am I scrolling with the mouse? Right. See your sibling min max. we store it in the parent. And then our node becomes, and then we become the parent node. And if we're not the root, right, so the root node doesn't do any of this. Let's have a think about that. Yeah. So, sorry, we would have already set the root node, right? Because the root would have been the parent. And then we would have just bailed. So that's fine. But why does the right-hand side... Could it be the traversal code? But it shouldn't be the traversal code because we tested a simple box, right? So let's open up render doc and let's just do a capture and let's just look at the data because it's probably the easiest thing to do. Oh no, I'm capturing 4 frames. Oh, it's only capturing one frame. Oh no. Yeah, capture me 1 frame, that's all I need. Cool. So let's hop into the data. We see in the box that every single time we change it, it flickers. Right, okay, that's fine. So we want to go to this one here where we can construct the BVH. We're gonna get the object, let's view the contents, let's view as BVH node. Boom. So, oh no, we got infinity. Ah, isn't that horrible? Right, so there's some infinities. Right, this is all fine. So it starts from about here. Yeah. So the only time we got an infinity was right at the end. Well, okay, not right at the end. So the left-hand side, right, because that's the left-hand side, it's a binary heap, right? So root, left, right. This is left of left. That's right of the left, right? So this is child of 1. This is child of 1 as well. So that one got an infinity for some reason, right? So it never filled it in the whole way for some reason. And then, so yeah, no, we should. I don't think we got NANs. The NANs that we saw was after the end of the buffer, because we only had 206 nodes. All of these down here are, yeah, they're past the end. So the end is actually here, 206. So we don't not got any NANs in the data, which is fine. So just some infinities. So we should be able to work with this. So it could be something to do with the atomic thing, right? You've got 206 nodes, each have a 32 threads, like processed in 32 lockstep. 32, processed in 4 waves, which each run in lockstep with 32 threads. So at the end, you'll get in one from one wave, a thread from one wave, and a thread from another wave, sort of like reaching the top. And it could be something to do. We might need to put like a memory barrier in here, although I'm not sure. So let's put the memory barrier in and just see if it fixes it. I'm not sure if we need a control barrier, probably just a memory barrier. I do not know. Now this is an AMD GPU, so we've got driver bugs. I think I'll just keep shaming them now until we get it fixed. It's so crazy. So damn crazy. Oh, it's just third party in it. No, okay. Atomics. Right, so we kind of want to just have a memory barrier for, let's just do a control barrier for all of it. It'll make it slower, but it's worth it to see if it is this problem. Right, still flickering, which means it's not anything to do with... On Windows, it actually has a problem on Windows as well, and on Linux. On Windows, it's a little bit more stable until 40 minutes later you get a blue screen. I'm happy with it, but when I'm doing serious GPU programming, it crashes when you have an infinite loop, or if you have an out of buffer. Sorry, if you have a buffer overflow, it will just lock the whole desktop. The stream will obviously go down, and I'll have to restart my PC. In doing so, it either takes 5 minutes if I were to do it properly, or if I hold down my power button, I can get it up and running in about 30 seconds again. But it's at the risk of losing my code, so every time I run a shader now I have to say sync to sync it all to disk and run the code. And then if it crashes I have to reboot stream, which is annoying. Yeah, MSC compiler outputs BV, yep, that's right. But yeah, apparently they're going to be fixing the bug soon, but we'll see. See about that. Right, let's litter these boys everywhere. See if that fixes the problem. Still got an issue. Yeah, it's infinity, isn't it? We saw the data. Why is infinity? So it's infinity because, and also you write like 54 in there or whatever. So you had infinity in the data set. That means we haven't written to the node. Oh, NVIDIA GPU, wish I had named the GPU. Yeah, so NVIDIA's probably got better drivers, but on Linux, they're not really integrated into the kernel, so they're a pain, right? Well, do you write any shaders that have like loops in them, or do you go out of bounds on an array index? I don't know. But yeah, I have that bug real bad. Just crashes the whole desktop. Right. So it has infinity in the min and max field because we reset them to infinity, right? So, but when the node comes by and overwrites its parent, like we never read from. Yeah, we never read from a node until it's been written to fully, right? So we only read from. It's only happening very late on in the shader as well. So we basically write to the whole parent and then we go up. And then yeah. So it's basically reading it here or here. Before. Very weird. Also, kind of BVH, do you use your own compute shaders to render the scene, or do you use acceleration structures on GPU? No, we just use a compute shader to ray trace it. But we're currently in our sphere ray tracer, we're not using the BVH yet, we've just splattered it. We just binned it per tile, screen tile, and we got smallest per tile. But that's got limitations. So we're trying to do a BVH version, so it should have acceleration from no matter where in the world we want to have cameras, right? Because it's got a limitation of one camera. And when you're doing stuff like shadows and lighting, you kind of need multiple cameras, right? Yeah, so we're trying to build a nice, a nice BVH. Hopefully it's good enough. So I've got damn infinities in this data set. Super, super, super weird. So you exchange it. See, it put 55 in there. It was really weird. Like, it literally put. So we put on the x-axis, it put 55. That's why the x-axis is not blasting off into infinity and beyond, right? Like Buzz Lightyear. It's just only the z and the y. So y is the x getting a value, but the other two are not. And then by the time it goes, so I think it was node. Yeah, so this one had the infinity. All right. Yeah, this one got the infinity from these two. These two sort of, I guess it started right in the value. It seems impossible. Yeah, okay. So I think. Right, so again, the way the system works, right, is you've got these two sort of like. Okay. So we start from the leaf nodes. The leaf nodes are literally just gonna. Yeah, so we start from the leaf nodes. Each thread gets a leaf node. And they calculate their bounding box around their spheres, right? And then, they both try and go up to here. And they go, has someone been past here yet? If someone hasn't been past it yet, they will terminate their thread. The second one that goes past will be like, oh, that means the other one must be finished. So I will put a box around my sibling and me, and that is now the new parent, right? And we repeat that up the stack. But the first 32 are all going to be running in lockstep. So they're probably fine, but as you sort of go past 32 leaves, you get these different sort of compute units running at different times. And they I think there's a problem where this sort of check, when this one terminates and the second one goes by, it's doing the check and being like, oh yeah, something's been here. But then when it tries to read the sibling's data, it's not been updated yet. So that's why I thought we needed a memory barrier. But it's not. Like, yeah, I think the cache is not invalidated. But it's not atomic mutations. Right, so that's the reason why the X one is visible. Only X is visible when we read from it. Yeah, so only the X component is visible when we read from min, but not the whole thing. Very weird. So it's very strange. Hey there, Sleepy Mushroom. with PCG in terms of bio generation. Is that sort of like random number, like procedural generation? Oh, okay, yeah, procedural generation. There you go. I think I kind of understand it, but yeah, not really my sort of wheelhouse. Or infinity on the end of the line. Yeah. Yep. So, yes, I think that's kind of the issue. It's something to do with you got another compute unit executing a wave, and another one executing another wave, each getting like as basically one active thread, and they're processing. They're trying to. The caches are out of sync, right? So you're getting a problem with the cache. But I don't know how you'd ever solve this. I thought you'd solve it with the so we should go to research into this with like a memory barrier. And I thought control barrier does the memory barrier stuff, but I don't know. So let's see if this solves it. So this will just say here, and it says the atomic mutations are done across, right? But anyway. Right, so we've got a bit of a problem where the caches, so compute shader flush caches. Does not care about caches. Caches, the model is built from the notation of accessibility and visibility. A value produced by GPU. By stage A, available GPU, stage B. Value produced by is visible. Hmm. Yeah, so we've definitely got barriers, but the problem is it's the same compute shader, different groups. Oh, there's this coherent thing, isn't there? Yes, I remember seeing that in DirectX. Maybe we need to mark it as that. However, if you have a GPU, if you want a GPU level understanding, it depends on the GPU. GPUs have L1 and L2. Yeah, in our case, that's true. Oh, even using the coherent should not flush. Hmm. Yeah, so apparently, and I'm sure this is the issue though that we're getting. Should we look into that sort of like HLSL globally coherent thing? Trying to make them both no idea to set them up. From what I understand, it's just terrain. It's just terrain at the moment. Right, biomes and stuff. Yeah, I think they basically use like noise. So if you've got like if you already generated, how have you generated the noise? Sorry, the terrain, is it with a noise map, right? But you can basically have another noise texture and just generate the biomes that way, right? Um, but yeah, I'm sure you can Google for different approaches, but I'm pretty sure there's just tons of noise textures. Globally coherent. Alright, let's figure out this bugger. Where is it? Can be prefixed with globally coherent. This storage class causes memory barriers and sinks to flush data across the entire GPU such that other groups see the writes. Without the specifier, a memory barrier or sink will only flush a UAV within the current group. Okay, so I forgot what this compiles out to, but if we go into Godbolt, this is so damn annoying. Why things are designed this way. Literally rocket science. Right, I've tried to do this before. Look, here's me in the past. So basically, there's an attribute, we've just got to find it. Coherent. Okay. So we need to probably modify HCC to get this to work. But it's fine because I wanted to modify it anyway. So there's a coherent decorator. Must be applied only to memory object. It could be an image or a storage buffer. This indicates the memory backing is coherent. Yeah, it just says it's coherent. That's all it does. Great, but what is coherent? Coherent is not allowed if the memory model is Vulkan. Damn it. A memory model is Vulkan. Huh? I think we need to look into this Vulkan model thing, memory model. Because we do use it. Right, let's see if HLSL... Oh, my days. Memory model GLSL 450. So should we move over to the Vulkan memory model and see what they produce? Vulkan memory model... Sorry, HLSL... We need to read this. Has HLSL got a Vulkan memory model yet? Ooh, information. So they released the memory model, gives developers additional control over their shaders, synchronizing access to memory in a parallel execution environment. The support of Vulkan memory model is added to GLSL Lang. In order to complete the picture, we want to explore how we expose it to necessary HLSL. Sorry, necessary concepts in HLSL. From HLSL's perspective, the following three components are needed to be supported with Vulkan memory model. This right. New constants. Oh my days. They want to add constants? Right. Oh. Are we not doing this acquire and release? Oh no, they didn't. Okay. I see what's going to happen now. I see what's happening. So we're using this Vulkan memory model, and basically our atomics need to have these sort of things added to them. Damn it. Is this really needed? I feel like this is probably where the bug is happening. But it's kind of a bit of an engineering effort to see if it is actually the problem. So new modifiers, volatile group shared and globally coherent are currently valid global modifiers. But it's adding newer ones. So Q family shared. So that makes it this sort of memory scope here. Oh my days. So these are the access masks. Wow. See, we could not use the Vulkan memory model and then just put the coherent thing on, right? That's another way to solve it. So we could use the older memory model and put the coherent thing on. That would be the quickest way to fix it. But let's read more into this memory model. Oh my days. This thing. Right, just jumps to the comments first, that's fine. Probably in the specification somewhere, isn't it? Ah, the glorious spec, here we go. But yeah, so I think the quickest way would be, let's disable Vulkan memory model, and we can enable the coherent bit. And we can just put it on all buffers or something, I don't know. Bring that new compiler in which does that. Damn it. And that will basically see if the problem is actually fixed with that solution. Then if it is, we can see if we want to do this proper Vulkan memory model stuff, or if we just don't bother with it. Because it seems like a lot of silly work to add in for now. Right. I can't really understand it because I can't really find the docs yet. Yeah, I did type it wrong, but it came up. Eh. Yeah, I typed it right there the second time. Shouldn't have. Right, let's have a look at it. We'll see if it's easy to understand. If it's not, we'll just do the simple thing. So there's program order, shader call, atomic operation. This is one we probably want to look at. I'm at the right one, aren't I? Yeah, I'm at the right one. So atomic operation on a device, SPIV operation whose begins with atomic is an atomic operation on the host is any operation performed. Right, okay. Each atomic operation has scope and semantics. Informally, the scope determines which other agents it is atomic is respect to, right? And the semantic constraints its ordering, right? I see. So the scope allows you to say it's going across the, right? So that means the hardware can be like, I've got these levels of caches, so it can know which ones it needs to flush. And then the semantics would be the ordering as well. So the compiler can order it correctly. Right. Yeah, it's equivalent to the C stuff. Right, I've got an idea. So I'm surprised why the compiler's not crying that I've done the scope. Wait a minute. Atomic add. Did I hard code the scopes and stuff? You add. I add? There we go. Right, so there's memory semantics. And then there's scope. Right, so I've hard coded those. But those don't have to be hard coded. Right. So if we take a look at Okay. So we take a look at the HTC source code, or not even HTC's. Let's just dump the thing. It's BVH. We'll look for like IAD, I guess. There'll be an atomic one in there. Right, so we've got a bunch of these. He's not. Oh yeah, 1 and then 0. Right, so 1 is device. So it's just across the whole device. And the memory semantics. It was none, so it was relaxed. Yeah, so that's probably an issue. We probably don't want relaxed. Maybe we need to change that. If we look at all the atomics. Hey there, Master Agent, how you doing? Yeah, so it's there. That one. Yeah. So that's definitely a problem. We should probably, so let's just read this. I'm pretty sure we can just do acquire and release. It won't be the most optimal, but it should be good enough. Like, you should probably manually specify this, but it should be good enough because we're doing it across the whole device. And yeah, so acquire on atomic operation orders the memory operations provided in the program order after the atomic instruction. Against this instruction on a barrier orders the memory operations provided in the program order. And this one's before, is it? Release. Yeah, before the barrier. So acquire makes it seem like, yeah, so you've got acquire, which allows you to reorder after this operation, and release means you allow to reorder before or something. And then acquire and release just means don't reorder this instruction, basically. So I think it's being reordered or something like that. I don't know. We should try acquire and release. We should put that one on. So let's hop in the compiler, let's fix that, and I think that should be our way around it without any of this coherent stuff. Parent ideas for a hobby project this weekend. Sweet. Take a gander. Nice. Is that in landscape? Yeah, yeah. Awesome. It's gonna crawl and come and get you. Right, I'll just be right back. Just need to get another drink. But yeah, after that, we're gonna just hop in the compiler, change this atomic thing, and then that should fix it. Right? Pretty sure we just need this acquire release, and that should fix our problem with the flickering. We're getting this sort of flickering issue, isn't it? Yeah. So I'm pretty sure that's the problem. So anyway, we'll be right back. Right, welcome back everybody. So, I think we can nail it. So let's hop back into the HCC project. And we just make one little adjustment. And that is, first I need to put in some changes where I fixed the while loop issue with if you have extra, more of a complex condition expression. But when we generate our spear V for any atomics, we have the wrong. Where's the bugger? Not device scope. Memory semantics, these boys. Excuse me. Oh, it's a spear VID. Huh. Oh no, it's a constant. So it points to a constant. Maybe it's not wrong? We need to find out what that constant is. So let's read the constant. So we've got constant of 0. So we go whatever u in. Oh no, it's 0. It is 0. You bugger. Yeah, obviously it is 0. Okay, that is wrong. So where did we construct that? Memory semantics of dispatch. What? No, something's really odd with this. Alright, what are we doing with these semantics? 0 for all. Workgroup memory, uniform memory. All shouldn't be 0. Yeah, we should need acquire and release. And all is definitely not 0. That's relaxed. Very weird. So that's probably where the issue was laying. But it's still not doing everything. Where's these memory semantics? So workgroup memory. Oh my days, this is all wrong. Okay. So all of these were doing the wrong one. I was filling in the basic after it was getting filled in here. That's been the problem. Hey, Cat Payne. He's up to the kid, sweet. Things are better than we thought. We have an older cat 6 years. Awesome. It's good to hear. Yeah, we've just been fixing some of these bugs, and yeah, we found out there's probably a HCC compiler bug with the atomics. It's generating the wrong code. But yeah, it's been going alright though. I think we nearly fixed the BVH rendering, and it's to do with the construction. I can go over the problem quickly. So the problem is we wasn't reading from the correct sibling node. We was doing like node XOR 1, but really it needed to be like this here basically. Like this is 0, this is 1, this is 2, and so on. 3, 4, 5, 6. What's happening is I was saying 1 XOR 1 and it'll give me 0, and that's not the sibling node, right? Then I'll say 2 XOR 1 and it'll give me 3. But what we really need to do is say, x take 1 XOR 1 plus 1, and that basically allows 1 to find its sibling node, which would be 2, right? And 2 to find its sibling node 1. And that's been the problem. That's been one of the problems. Now another problem that we've landed on is for some reason our value is for this min x is fine, but y and z are infinity on one of the root nodes, and I think we found out it's because of the atomics, and due to the Vulkan memory model, we've not put the correct I thought it was going to be a complicated thing, but turns out our scope, so it's a bit like C and C++, right? We got this acquire and release. We've got it on relaxed. So it's not, so it could be reordering the instructions and messing up with some of the it's reordering some of the instructions before the memory barrier, right? Or after the memory barrier, something like that. So like by the memory barrier that's produced by the compiler when you do an atomic operation. There's something along those lines. So we've just got so looking at it here in the compiler, we're initializing these constants, but they seem to be off by 1, some of them. Is that right? No, scope devices is fine. I should probably do something like this. Just make it clearer. Make it easier for my eyeballs, Right, that actually seems okay, damn it. So it wasn't wrong. 8. What's going on? I'm so confused. It's putting in 0 in there. Yeah, so this is probably fine then. So, right, so this code is probably okay. The issue, let's undo that then, actually. The issue actually arises from when we generate the SPIV instruction. So when we generate an atomic IAD, okay, we generate the atomic IAD. When we generate it, it's putting in 0 in there like an absolute scrub. That's the problem. So this needs to be CU. And let's just, it's probably not the most optimized, but it's probably fine. So we just need to put in memory semantics all. So I'll put the acquire and release, but I'll put the other things in there as well. But if it works, then that's good. That's obviously a much better place than we're in right now. So that is for the add. We'll look around and see if there's any more of these guys, right? So there's atomics there. No atomics there, right? Right. There's a compare and exchange. We use an exchange, actually. Oh, so that's in there. Good. So really, let me take that. So the compare and exchange. Compare and exchange. Scope, memory semantics, unequal. Damn it. Yeah, we'll put them both on the same. Ooh, there's restrictions. Unequal must not be set to release or acquire and release. In addition, cannot be set to a strong. Okay, so we'll just set it for equal then. That's fine. I'm not sure if that's fully correct, but there you go. So, you know, we shouldn't need on a store, we shouldn't need any memory ordering stuff, right? We just want acquire, isn't it? Oh, sorry, release. That's what you really want. You just want release, but let's just stick it on there anyway. And then for load, you just want acquire on the memory semantics. But again, oh well. You can always make it better later. Right. So that should be the new compiler. So what we're going to do, just quickly open up a new one of these boys. Do a git status quick. It's fine. Let's do a new release build. So we'll grab the release build. This includes my new change as well, which fixes the while loops. So we're going to run it, and it should have fixed the problems. So HCC, let's get the build. We just need. Damn it. Let me go into libhmass for a second, and let's make the vectorized sum element, because we use the sum element now, and it's for a boolean. It's pretty cool. So we use this to check if we've hit the edge of a box. Sorry, the literal edges of a bounding box. So if we've hit 2, yeah. If we're close to 2 of the edges, then we've hit an edge. Sorry, 2 of the faces, we've hit an edge of a box. So let's just plop that in there. Plus the Z. That's the one we use, right? 3D, obviously. Then we get the 4D one in. Cool, so let's put those in there. What we'll do is quickly compile that again, just in case it breaks anything. Cool. So we get the release package. I need to update the version number soon. We get a new release out soon. TM. We'll drop in that one there. I want to quickly. Yes, I've only changed that today, I think. Git diff. Third party. Yeah, we only changed that today, so we're going to change it even more. Add the new ones in. And voila. So now we should just be able to close the compiler and get back to business. So we recompile the whole game. We should hopefully not see any more problems with this BVH. And away we go. Right, if it crashes, whoops, it shouldn't crash. Right. Damn it. So we still got this problem with the infinity, but we can at least check the compiled output and just make sure we've got this acquire and release on, right? And then we should look at our scopes more. Oh, do we do buffer? No, not scope. Scope is fine. We did device. Yeah, you don't XOR that, that's fine. What's the other one? It's like, what's the acquire release? Memory semantics, this is it. We're putting out to a buffer, aren't we? There is an image one. Image memory. To constraints with output storage class memory. That's fine. Yes, pretty crazy. Pretty bananas. Should we quickly look at the code again? Tab new, HCC, source, spearv.c. Right, we had those memory semantics. So we did memory semantics for all of them. Here it is. So we're doing acquire release, workgroup memory, uniform memory, image memory. I don't know what I can say. Maybe there's more. The atomic counter storage class. I didn't know that was a thing. Acquire release. Right, it's 8. Sequential. We've not used that. So this one. Applied to storage buffer. That's what we're using. Interesting. So 4.0, we've got that one in there. Boom. And that's one we're applying it on. Workgroup memory. Yep. Seems pretty good to me. And we're using device, which is 1. And that's what we saw. It was 1 encoded in that thing. So let's just check our thing again. Ah, you bugger. Right, it's got a new number in there now. 2376, and that would be in hexadecimal form. That would be, you know, all those things all together. There's definitely changed now, but we're not seeing any effects. Yes, that's the point. It's not going. Not all of them are infinity. We'll open up in RenderDoc again. This is the weird thing about it, right? Not all of them are going into infinity, just the y and the z values, right? So what that means, so super dodgy. Right, so let's open up our shader which does the construction, which we'll look at in just a sec. We'll go to the buffer, see the data. So this view format. So, okay, that one's fine. Well, the 4 node has got infinity. Why did 2 not get infinity then? That's not right. That's weird. But yeah, so see here how when it gets these infinities, this is where the problem happens, right? Only the x coordinate is... Oh, it's max.x. Huh. Was I looking at this all wrong? Right, let's look at the exchange quick. 2 seconds. Right, so exchange is that same memory ordering thing. That is fine. And there's an NAN, right? So we've got that new memory ordering thing in. Or semantics thing in. Still got the same problem. Right, so I was reading it a little bit wrong. It's only the max which has the problem. Right. So we do the atomic exchange. The second thread that comes through here. So it's binary tree, they both go up to the parent. The second thread that comes through has NaN here, right? Yeah, I wonder if we could put the barrier back and it would help, but I don't know. Put them everywhere. Still got a problem. Yeah, so the max is the one with the issue. We're saying max of the sibling node max and max. So when the sibling node has infinity in it, it will just pick up infinity. But we should never have infinity in the sibling node. So the only time it's introduced... Yeah, so ignore these guys. Because 206 is the first one. Yeah, the last one rather. So the first time when it happens is here. Just randomly out of the blue. So you should never be able... When you read from here, it should never be infinity. So let's plot this out a bit, right? So you start off on the leaf nodes, each thread gets a leaf node. They both build their bounding boxes, or they all build their bounding boxes, and they go up the tree. So everything is cleared to infinity. And they take the min.x of the parent node, and they atomic exchange it with NaN, and get the original value back. Right? Read the docs for that quick, but the so the exchange gets the old value back. So if the old value is NaN, it means that it's been exchanged twice, right? So that means we're the second and the last thread to reach this node, this parent node, which means the sibling should have had its rights written to. Is that going to be correct? Yeah, because you would have gone up to the parent. Yes, this one would have gone up to the parent. It would have been like, is there anything here? Or has someone come past here yet? No, I'm going to terminate myself. Wait, are they not terminating? They're going to keep going up. That's the problem. They're not... Right, so I used to have code which terminated, but now I don't. Okay. So you probably just want to say else. Like, I'm the one that gets to go up. Else 0. Like, I could say break, but it does something with the control flow where it's just better just to set a value. Okay. So that's going to terminate the thread. Okay. Right. If the stream dies, whoops, but it should be back. Right. This definitely seems better. We're getting less problems, but it's still flickering. Should we have a bit of fun and try and render the whole tree again? And bearing in mind, we've got the new compiler in, which means this bug should be fixed. So should we try that out quickly? So now we can use this we can use the short circuit operator in the while loop. There's a bit of a problem with the basic blocks, the way they've been generated. Let's try that. Shouldn't crash, but hopefully it doesn't. Right, same thing. That's good. That's good. That's what we wanted. So, wait, since you go. Oh yeah, I've already answered that one. Right, let's remove this. And so you should see the whole tree now. Excellent. It's pretty cool. So the colors represent a level, right? So how the depth they are down the binary tree. So the first one is brown, because that's just the way it ended up being. So there's only 2, but the next one has 4, and the next one has 8, the next one has 16, right? So you're able to see the levels in that in this BVH viewer. The problem I'm sort of having, though, is obviously it's still flickering, but the beauty is we can just run it in render doc again and do another capture. And it's probably got, it's another infinity, right? But it's be interesting to see which one had the infinity. Okay, so I've caught it on this right now. So, you know, the first one might not caught it. Right, so that one didn't capture it there. That was a good frame. This is bad frame. Did I ever message the RenderDoc guy about some kind of bugs you were mentioning? Yeah, so back when HCC didn't used to work for RenderDoc, I did try and fix some of the problems, and I kind of got as far as I could, and I sort of like gave him reasons why it wasn't working, and literally within about 6 hours, he had a fix for it in the latest branch. That's why I kind of got it in a Git repo here, but since then it has been released. And then there was another slight problem, and then he fixed that. And then there's a problem in my compiler, so then I fixed that. But he was really quick and awesome at fixing it. Like, you know, it's pretty difficult to understand the code base, but he seems to just do it really quick. So, you know, hats off to him. Is the vertical Y? Yes, that is true. Yeah, vertical is Y, Z is depth. But yeah, so we check in the resource. Yeah, so what's really crazy is basically the RenderDoc guy, the single RenderDoc developer, right, is much better at dealing with bug tickets than the entire teams at AMD with their driver. I've filed a bug before, and basically the guy lied to me about the bug not actually being there. And I had it confirmed by like 3 other people on 3 different machines running RDNA 2 and running it on RDNA 3, and it didn't have the problem. So I definitely narrowed down where the problem was, and the guy literally just like, he just said it works fine on my machine, which basically meant like, okay, but is your machine an RDNA 2 machine? Like it was very open-ended, his response. Like it didn't mean anything. But I didn't even get past the QA basically. Pretty crazy. But anyway, where's my infinity? I'm not seeing infinity to infinity and beyond, you know? I'm not seeing it, but we see the box. So, huh. Oh, we're seeing it now. What? Oh. What's that second dispatch? Did it become infinity after? Am I running a shader twice? Okay, that was weird. Okay, this one's the full screen sphere renderer. This one is the BVH viewer. So what's happening? Okay. Alright, so okay, I see what's going on. So basically RenderDoc is running. We've got to try and basically RenderDoc is running the shader or something like that or interpreting it. And every now and then it's sort of like getting the same yeah. Right, we got it. So it is happening on this shader. This one is the one where we calculate the BVH. We construct it on GPU. Yeah. Right. So we're getting it on the 4, which is chart. Yeah, so it's the right node. Oh, no, it's the left node. Why are we still getting this? But we're getting it less now. Which is weird. Hey, today, Hooligan, how you been? Welcome back, welcome back. How's it going? Yeah, so the left node gets... Again, it's on that max again. It's weird. Should we put memory barrier in and see if it fixes it again? But it's happening in the construction. But we did just fix it. We literally just fixed the problem. Wait, how did I fix it again? Oh yeah, we had to terminate the node. Oh yeah, terminate. Terminate the thread. Okay. We are the first thread to reach. It could be something related to this still. We're the first thread to reach this parent node. Terminate the thread. So maybe the same bug is still possible, but by having less threads doing stuff, it was causing it to happen less. But why is NAN test on the X only at the start? Because you choose the... No. So it's because we just exchange on it. Right, we're using min.x as a flag. Right? We're using it as a flag. The first time we come by the parent node. No, we're just using it as a flag to say, like, has something been here yet? If it's been here yet, the value... If another... So there's only 2 nodes that can come by here. Right? So when the first node comes by, we swap it and put NAN in there and take a value out. If that value is NAN, it means it swapped it twice. Right? Because we clear the whole thing to infinity. So first time it swaps it, it's infinity. Second time it swaps it, it's NAN, right? So the first node, so this one goes to the parent, it swaps the min.x, right? We're just using it as a flag. If that value is, so we swap it, we get infinity back. It's not NAN, right? So we terminate the thread. The second time we come up from the other node, we swap it. We swap the min.x value and we look at it, it's going, oh, it's NAN. So that means we can guarantee that, you know, this sibling thread is finished writing to there, so we can just do a bounding box around them both, and then that's our bounding box of our parent, right? So it's just a flag. So I'm thinking, so before we added this termination, terminate the thread, and allow the sort of other sibling to continue, right? Meaning our sibling data will be set and set ready for us. You're ready for us to read. Something like that. Okay. So before we had this, we had multiple threads, like more than 2 threads going up the tree. Right? And it was causing that infinity thing to happen more often. So should we have a way So I was having ChatGPT work on 90% of the JSON parser. That's funny. Oh, excuse me. Rightio. Copying, yeah. Right. So you've got. So is there a way that we could tell if more than two threads have come by this node? Basically, it's always the left one, and it's always left of the left which has the initial problem, and the yeah. So it's always this. Okay, this one has the problem, and then this one has the problem. So why then, when we have one which is like probably 8 deep or something like that, 8 levels deep, and so on, right? Why is it that this one that has the problem, and then in turn this one will also have the problem? Is the max value? See, if we cleared it, if we cleared max to negative infinity, like we cleared it to negative infinity, the problem might go away. But that shouldn't be. Yeah, it's flickering, right? It's still flickering. We're not getting it into infinity, but it's more apparent. There's a few boxes which have the problem. Right, but part of me just wants to bring the animation back, just so we can see it. Let's bring the animation back, shall we? Oh yeah, look at that. Look at that BVH. I'm not sure how good it is, to be honest. We'll have to cap it to like a single we'll have to cap it to like a single like level so you can see all of the so you won't see all of the levels being rendered. But yeah, it's still buggy though. It looks nice though, all the colors in that rate, but there's still a bug. It's still flickering a bit, but we're getting close. I just wanted to cheat and celebrate a bit. Right. So there's still like a bit of a weird issue. Like a bit of Morse code happening here. Beep 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 beep. Beep 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 beep. Why? So is there a way where we could so we so we could store a number that's incremented. Um How come the vertical seems to go far away? No, it's because the y and the z are infinity, right? On the max. Yeah, it's the y and the z. They're infinity. For some reason. So you'd only get the infinity if the sibling has not been fully written to yet. And you're the second thread to come through. Yeah, so I have a feel we've got to have a way to sort of store in the min dot x like we could just atomic increment. and then if you atomic increment and get back a value, so we can clear them all to 0. Yeah, we clear them all to 0 and do atomic increment instead. But you obviously don't want it to be 0 because technically your boxes could be on 0, right? And you're just basically gonna yes, the problem, the boxes are going to be on 0, isn't it? So you'll come into here, you do atomic add, and it will probably be, yeah, I was going to probably say, you know, if the atomic add and the old integer was like above 2, then it's a problem. Yeah. I think that'd be fine. So for now, let's just comment these out, and then we'll just we'll clear them all to 0. So 0 is 0, 0, 0, 0, 0, 0, you know, in bits. And so 0 float is 0 in for an integer as well. So if we literally do this, get rid of the conversion, and we'll do an atomic add U32. Got your value. If your value is equal to 2 or 1, with the second one to go through. And then do an else if. So let's just make sure this works first. It doesn't crash the computer. I refrain from asking, does it render if all pixels are done processing? I'm not sure what you mean. I'm not sure what the question is, sorry. Right, so it still renders fine. So now we should be able to check here and do an else if. And we just want to make sure, so if we've visited here more than 2 times, we're just going to print out into our buffer, whoops, and we'll put the number in. Like that. Right, so I'm not seeing a whoops. And let's just double check that, right? Let's move this to here. Right, so we're seeing whoopses now, but that's a 0, that's fine. But we're not seeing a whoops, right? And it's a U32, which means you don't have any negative state, right? It's all going to be, so if it's equal to 1, it's going to set it. Zero, it's going to go down here and terminate. Oh my days, we didn't terminate it. That's still not a problem. Yeah, still not an issue. Oh no, but it didn't even get called. Sorry. Yeah, it's bloody weird. So what we've just ensured now is the parent node never gets visited more than 2 times. It's always, because we clear it to 0, we clear them all to 0, right? And it never gets visited more than twice. So how then Could the max? Like we could just switch to atomics. We could just flat out switch to atomics and it could just fix the problem. But then we're doing more atomics than we need. Should we try it out though? Yeah, you'd only get 0, but you still see the flickering, right? Can you still see the flickering here? Yeah, so it's becoming 0. It's basically becoming nothing and coming back. Or it's doing something weird. Yeah. So... very weird. So what... So we could make both of these atomic, but you'd have to do an atomic load. And it's only the max which has the problem. It's not the min. Right, the min doesn't have the problem. But if we were to make the... And the reason why is because it picks the maximum... Right, if we made this negative infinity... It should still have the issue, right? Yeah, it still has the issue. Yeah, min doesn't have the problem because the min between, infinity and 3 is 3. But I'm confused why max has the problem. It just must be the way this sort of caching stuff works. I'm not sure. So with a second node to come in here, calculate the min-max bounds. Sweet your sibling node. We know that's correct. We fetch out the min. We do a min against our min, right? And that min. Then we do a max. Right? Then we just store them back into the parent node. Then we go up to the parent and go run again. Super confused. What does bits 2 do? We just convert it. It's just basically a reinterpret cast. So it converts it from a U32 into an unsigned 32-bit vector. Because we can't use atomics. We have to use atomics on an integer. We can't use them on a float in shaders. So we basically just convert them into an integer and do the atomic operation. Basically. Yeah, is it possible to have a data race between the min and max? I don't think it is. Because we're doing the atomic exchange thing. Not all hardware supports it, Crimson Mania. Yeah, it doesn't support floats. You can add it, but only like a small percent of hardware supports it. But yeah, I'll think about this data race thing. Should it store V back into... No, it doesn't have to do that. Because the first time is going to store NaN, right, into min.x. It's going to swap it. It's going to take infinity out and then store NaN in there. The second one comes along, exchanges it, stores NaN in there, and gets NaN back out. And then because it got NaN back out, we know it's the second one. So that's why I'm pretty sure there's no data races. Right. So, when you're writing to your sibling, then you write to your parent. Right, there could be a data race here. Could there? No, there couldn't be. Because the parent would have been... Right, let's get the Milton up. Pretty sure there can be. Right, so you've got your other chats there, isn't it? Damn it. So this one comes up to here. Has anything been up here yet? No, terminate it. This one comes up to here. So this guarantees that the sibling has been, your sibling has been here, and it's written its stuff here, so I can read it, right? But there's something I've not checked, and that is so your, yeah, this is fine, right? And then you'll store it in there. You'll calculate the bounding box and then store it in there. But imagine if this side did all of that first, and then it got up to here, and then went up to this parent and done the same thing. It would have got there and then terminated, right? So then this one comes up, and then does the exchange on the min.x, and then it does the bounding box again, and then sets it up. Yeah, I don't think there's any data races. This seems pretty solid. Although there is a problem somewhere. Right, so you go up to the parent, do the exchange. If the second one's come through, okay, then you can store it in the parent if you're the second one to come through. Right. There shouldn't be any data races. The sibling will also be free because you only come in here the second time around. You only come in here the second time. So if this one come up first and went here and then terminates it, right, because it's the first one to come up, and this one was still down here doing these guys or whatever, you wouldn't have bothered like yeah, you wouldn't have set anything in here and screwed anything up. And also if you were you know, this one was terminated and this one's like done all these guys or whatever and made bounding boxes. Now it's going up to here to set this one. It's realized it's the second one to come through. It builds the bounding box. It's able to know that no threads are processing this, and then it can build the bounding box and then store it in here safely, right? Because it's the only thread to come in here. Sounds pretty solid to me. There's just something weird going on. So if we made these atomics, then it probably fixes the issue. But I don't want to make them atomics. Sorry, we atomic load from it. But let's just give it a go, right? So we'll make them integers, but they're not integers, they're technically floats. Right, so pop back into here. We get a bunch of compiler problems, but no worries. So what we actually want to do is do it one by one, because I haven't got the atomic vector stuff in yet. Something else just to do. Let's see if that fixes it. We've got to fix some other problems. But if we do 3 atomic loads, and the max between all those, y, z, cool. See, it's when we store, is it when we store it? Is it the store in the parent, or is it the read of the sibling, which is the problem? Yeah, it's another interesting thing to take away. Right, we need to quickly just do a few little fixes. What is this doing? Why we write max before min? That's another good question. But really, min probably doesn't have the artifact because we've put positive infinity in. But if we put negative infinity, yeah, that's another thing to test out as well. Atomic load U32. Cool. Wait, what? Oh yeah. All of the changes. Right, nearly there. This is the BVH viewer. Right. Jobs are good, hopefully. What is all this? Oh, let's delete this. Validation error printing stack trace. What is going on? Why have we got validation error just changing struts? Did we use something illegally? Did it F? Did the stream go down? Been pretty fun on my end. No F. Okay. F on program. Okay. Yep, we got F'd. Right, atomic load with memory semantics release. Yeah, see that's the problem. Okay. I was being a bit lazy there. Let's fix that in the compiler quick. Right, so open up a new one of these tabs. Let's quickly just jam this in. Oh, come on. Oh, you bugger. What buffer is it again? It's BV, let's close that. Right. So the memory semantics for load and store can't be acquire and release. Load. That's just this needs to be acquire, which was 2, I think, and then release was 4. Just the way it was. Acquire. Yeah, acquire release 2, 4. So load, we just want acquire, and then for a store, We want release. Is it the right way around? We've released semantics. Cool. Right. So we need to add these boys in. Load, store. So when we do our BVH, atomic store. So this will just get the all store one, right? So be without the acquire, but with release instead. Then we probably just want to copy paste and do that load and bring the load over. So we'll load down here, which is reuse of all this stuff, and it's kind of like automated and all that, right? But well, yeah, it's kind of like just they have the same sort of thing. But yeah, anyway. We'll just do it this way instead. We'll change it around. So we've got, I think you only... Oh... 6, which means we need 5. Why is store less? Oh, because there's a result ID. Right. I need a type. Type. Return data type. Let's get that as well. Right, so you need 5 operands because ours is 1 less. Because that's 1 operand here, which has the opcode and the number of operands in it. So the 2 U16s, and that's 1 U32, and then the rest are always U32s. Just the way SPIRV works. So you got 5, right? You've got result type. In you go. Bob's your uncle. You got the result ID, which is operand 0 for load. Then you put in that. Yeah, sorry. So that's the. Yeah. What is pointer? Device ID. Oh. Right, an operand 1. That's the pointer. Then device ID, then memory semantics. That'd be the load. Right. Boom. Let's just double check that quick. So 5 operands, load 0, 1, 2, 3, 4. Yep. Return data type. Yes. Because 0 is the return register or return operand, right? The result ID for it's been returned into is 0, and the source, which you're loading from, the pointer is in 1. Scope semantics, sorry, scope, and then memory semantics. Boom. Oof, that ought to be good enough. Compiles. If we quit that, we can do a build. Grab the latest release. We only just need the compiler. Excellent. Let's bail on this and let's give it let's compile the whole game again. And if we run it, it'll be fine. Right. Okay, so we're not seeing any flickering anymore by using atomics. I don't know how I feel about that. Um, it could be to do with the memory ordering stuff. I don't know. It could have been. I don't know if it's data. I don't know if it's a data race because we never we just atomic load, right? We literally just atomic load. The only time we ever store into here is here, and this is not atomic, right? So it could be something to do with like a memory barrier going down or something. But then it's a sort of a low level sort of like memory barrier. Because if I was to put in a, you know, one of these memory barriers, it doesn't, like, it still doesn't work. But yeah, I'll try what you're saying. I'll try the other order. We're gonna undo all that. Um, so we know this works. We can always just do this and then carry on with the game. But it's good to understand where the actual problem is, right? So let's keep going. So it's in GFX. Right, let's put that back to an F32. So run this now. We've got the flickering still, yeah? So what Akraz was suggesting is we simply just, right, we'll flip this order and then we'll flip this order as well. Because what's the problem is actually the store into the parent node. But, oh no, that's the thing. We don't know if it's the store or the load that's the problem. So we're going to hard code a value and see what the problem is in a sec. Right, so that didn't fix it. Now let's swap these two around and see if that fixes it. No. Yeah. Like, yeah, we should try and understand the real problem, you know, basically. Oh, right. So that doesn't work for some reason. So, so my other thinking now is, how do we know it's not the read? Well, if we simply just max it with a constant, we should be able to know if this is the issue, right? Because we're going to have some constant. Wait. Should we put our own infinity in there? No, infinity is already in there. We're going to put in 0. So we maxed it with 0, which means it should never go past the middle of the screen. Yeah, but then things could be negative. So we max it with min, which means things are going to be 0. So let's do min add. Ugh. We'll add like, I don't know, 1. I don't know, 20. Ought to be good enough. So if we see the infinity happen here, then the problem is the storing. Yeah, but we just did a load and it worked fine. So it probably is just the load then. But anyway, let's do it from this angle because it could be both for some reason, which will leave me even more confused. What? What did I just do? Right. Yeah, no, right. Confusion. Right. So we did like a min plus 20, which means everything is always... We're still seeing the flickering. Right, so we know that the problem... Wait. Hang on a minute. I've got to think about this. If I just did a +2. Right, those are not in anymore. Max plus the minimum n +2. Yeah, so we're still getting we're getting infinity. Yeah, we're not getting infinity anymore. Should we look at the data a bit? So we've done min add 2. I don't know why we're seeing it so like why are we seeing it cover the whole thing still? Or most of it at least. We're only adding 2 to the XYZ. 2 isn't a lot. 2 is like the size of a ball. Right? Oh no, we're picking the max of it. Yeah, okay, that's fine, that's fine, that's fine. Jam on Toast, welcome. So atomic read and atomic load are the same thing. That's what atomic load is. Oh, and not load the other. Sorry, I misread you there. Sorry. Can you atomic read and not the load? See which. See, I'm not sure what we mean exactly. See, that would help. Um. Yeah, it's not specifically like, both. Hmm. Yeah. I'm not sure what exactly you're referring to. Sorry. Um. Yeah. So, what we've just guaranteed then. Yeah, the siblings shouldn't have to write with it with atomics because the siblings should be done. Because this is the sibling writing, right? It writes to the parent. Like we've guaranteed it's finished. It should be finished. Like we've guaranteed that. It's just so it's still flickering, and it's still flickered. So we've removed. So what was interesting is we fixed it. If we done an atomic read on the max, right, and it fixed it. But now we've gotten rid of that one entirely, and we're just relying on the atomic, sorry, on the min, right, and then storing it in here, and it's still broken, right? So the interesting thing is that, yeah, like we're going both ways, like. Oh, it's just weird. It just makes me feel like it's a caching issue, but we have no ways of fixing it. Like it's like something. It's not flushing like at the L1 cache, and it's in another compute unit. They put a memory barrier in there. It's still fine. It's still going crazy. Hey there, TK Dev. Thank you so much for the raid. Welcome, welcome. Hey, how'd the stream go? The value is not writing with atomics, is it? So the value can be stale when read. What do you mean? I'm not sure what you mean by stale. Can you define that a little bit more, please? Right. Hmm. So let's try an atomic store it and just see if that fixes it. So we've tried atomic reading. That fixed it. Let's try the atomic store. Because it's not synced between threads. Right. Yeah, I don't know why that would happen. Yeah. So yeah, I can feel like, yeah, I can understand, like, from a caching point of view that the cache has not been invalidated, right? Oh, it needs to be marked as volatile, doesn't it? Maybe. Right. It needs to be a volatile read or something. Where it actually reads from main memory or the. Right. Um. Mm, weird. Can you write max perform in and add a barrier? Yeah, I could try that. Or then add a memory barrier. Let's just do an all one. But yeah, I can see the point with the caches though, but it's still. Right, still. Nope. But yeah, maybe we should just move on and do the atomic thing. But still though, so we did one atomic, so it could be volatile, right? But we can't get a volatile pointer. Like, there is a volatile in the interesting. Oh, right, it's in the memory semantics. It's in the semantics, so when you do the atomic load or whatever. Not it. So volatile is not allowed in the Vulkan memory model. So you can't have volatile in Vulkan memory model. Instead, it's in as a memory semantic with that acquire and release stuff. But this is not going to be useful because we're not using volatile and it's still working. So it's the act of using it as an atomic. It works fine. Yeah, I guess we just have to put the atomic in there. I guess the GPU is not able to sort of know what caches it needs to flush, right? It does kind of make sense, but still. Um. So yeah, let's bring the atomics back, which means we have to literally just do this, right? Come on, you jumped to the wrong damn thing. Right. Okay. So these are actually F32s, but we use atomic exchange or load and exchange on them. So they must be integers. Preface. So yeah, let's go back around and do this. So we might only have to do one load. Maybe. That's still a bit silly though. Yeah, so I think it's on the load. That's the problem. But yeah, let's go around and fix all of this first. Alright, nearly there. Oh, it needs to be a bit too. My mistake. Right, so obviously still got the problem because we didn't do the actual atomic load. Right, you think I should do atomic load and store? Fair play. You know what we need to add into HCC then? We need to add atomic load and store for vectors. Because yeah, we should do that right now. Because it is supported in SpearV. Yeah, it's actually there. We just got a bit of a correctness problem. Yeah, we've got a bit of a weird, like it's reading old CPU cache, GPU cached data, and it's flickering. So we've got to use atomics, even though we're technically safe. It's very weird. You don't think I need the vector stuff for correctness? Yeah, but the problem is I have to do a vector. The problem is like it's not the correctness part. So are you saying I should just have to load from X? Yeah. So the thing is, right, is I want to make it so I can just do atomic load F32 times 3. Instead, I have to do F32 and do it manually and repeat it. So I want to just condense the code a bit. So I think I'm going to... So this works... Oh, it says it must be a scalar. Alright, I guess we won't do it then. Yeah, there's no vectorized version of it. But for exchange... Okay, I guess we won't do it. We're going to do it manually then. Fair play. I think I saw it for atomic add or something. That's why. Okay, so repeat it 3 times. Wait, what are we doing? We're going to do like a... atomic load E32 address. Get rid of that. .x. 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 So we want to do that, but for max, let's just do that afterwards. Right. Repeat 3 times. Z, Y, Y, Z. Nice. Repeat that. Max. Sweet. So that will fix the problem, but for correctness, we should probably do this. Oh, Max. Thank you there. Akraz, appreciate it, sir. You can't actually. There's a bit of a problem. In SpearV you can't cast pointers. So when you make a pointer, so we're making a pointer to something in a buffer. we can't technically do that. Like, there's a hacky way I could achieve it, but it requires a bit of hacks. I would basically have to declare this structure. I would have to declare every time I have an F32 in a structure, I'd have to declare an integer version, and then I could technically say there's a buffer with this and sort of index into that buffer and get it that way. But it's just super hacky, basically. Oh, with the reinterpret. Yeah, I could do that. Yeah, that's the shorthand way of doing it. Not a bad idea. Right, so atomic store E32 address of wait a minute, these are times threes. Dot x. Oh, why is the GPU so hard to program? Why? Okay, that ought to be good enough. Give that a go. Oh yeah. Right, let's just roll with that. Let's roll with that. So, what is the next sort of thing to do here? So we should probably commit this code. Let's bring the time back, right? We should always bring time back. So we basically generate the spheres at different points along. Well, we generate the spheres every frame, and we have it like a sign, you know, on the Y or whatever it is, and blah 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 blah. So, woo. Because it's technically more correct. Yeah, I'm not sure why we need the atomic stores actually. We could probably actually remove those. Can I check the performance? We shouldn't need the stores. The loads make sense, but the stores don't, right? That's a good point. Because the loads exist to flush the caches, but the stores don't need to flush any cache because they're just setting memory. You would have to assume that the hardware has write back caches though, right? So you have to, like, the hardware, actually though, that might be true. Like, if I, say if you have like an L1 cache, so you have like your, your CU, your compute unit, you have your L1 cache, the L2 cache, which spans multiple. See, it all depends on what the hardware is, right? L2, and there's maybe like another L1 with like another CU in here, and blah 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 blah. So this one writes to that, stores to the memory location, but if this L1 see, I'm not quite sure on this, but some caches can be write through or something like that, where they can basically write back, it will automatically write back to the L2 cache, right? So with an atomic, it might sort of explicitly flush the cache, right, back to the L2. The writes back to the L2. It all depends on the hardware, I think. Just a guess. So maybe we do need the stores in there. Hey, pleasant like 2. Sorry, I can't really help with web development. Um, doesn't this flush on kernel end? The problem is we don't want to have. We need it while we're within the same compute unit. Sorry, compute shader. Like we're communicating across compute units, running the same compute shader in the same invocation. Yeah. So we might need it on the store actually, thinking about it. But let's just see the performance. Let's see that performance, shall we? So it was 0. Yeah, 0.03. Right, 0.02. So we kind of lost a bit of performance there. It's kind of, it's like a third better. So for now, no, memory barrier won't work. We've been trying memory barriers. Should we put, I think I'll put a nice lovely comment in there. Let's see what the performance is with a memory barrier. Our performance is still roughly the same. Okay. So I think let's just write a comment here. So technically we shouldn't need, okay, so maybe theoretically, right? How does one even spell this? That one. English. Right, theoretically, right, we shouldn't need atomic loads here since our sibling is finished. But this compute shader can be ran or is going. Okay, what's the best way to abbreviate this? So, but this compute shader, okay, runs across multiple CUs. With different caches, atomic load basically should flush we had issues with this on the AMD 66 or RX something like that. Cool. Yeah, technically we might need it on the store. Warning, if there is flickering, right, with the sort of bounding the BVH in the BVH viewer, then the issue is we probably need an atomic store here. for the sort of inverse, or sort of like for the same reason as mentioned for the load. So yeah, it doesn't really impact performance a lot. It's like a third. It's a third faster if we don't do the atomic stores here. I wonder what. Let's remove the atomic load. So obviously it's going to be maybe a third quicker again. Well, yeah, it was twice as fast, basically. So we, that sacrifices, yeah, it's just twice as slow doing that, which is a shame. But anyway. Theoretically, we should need some memory synchronization for all stores and loads, including the store of min-max in the leaf node above. Right. What do you need? What do you mean by memory synchronization? Do you just mean the atomic store? The atomic store, is it? Do we actually need this stuff? If so, I might as well just put it in. Right, okay, screw it, let's just put it in. Yeah, let's just put it back in. Man, it's so damn, like, to figure this stuff out, you literally have to, like, it was so weird, like, I'm not sure what documentation I could have read, which would have been like, oh yeah, like, and just understand the problem. I literally had to, like, figure this out with trial and error. Like, when you read documentation around memory barriers, it doesn't really tell you much either. What kind of games are we trying to do with this engine? Not sure yet. We're just building the base layer first. So we're building like a nice solid foundation. So we've got like a bit of UI, got like a bit of graphics in there, like a GPU abstraction. We've got a bit of controller support. Right, we're just building the base engine, right? Kind of bare minimal stuff that we need to prototype. We're currently working on, so we're trying to build some form of solid foundation here, so we can build on top of it. And when we, so sort of like, yeah. So there's another one, like we're doing, like, what's this other box? We can call this other box. So this is like our graphics R&D. And some of these will be more solidified, right? We'll just be like, so this one will probably stay as it is. Like, oh yeah, we know we're going with spheres and we're ray tracing spheres. And we know we can probably extend it, but we're not really going to be rewriting the core design of this box, right? We'll just extend it. But yeah, we're sort of trying to basically solidify some things or know how we need to extend them first. And enough so we can prototype. And then we can then do the same thing for the game design. We'll have some restrictions and limitations we can work with. And build a game design and have, again, some core things which are not going to change, like, and then we can, but things we can definitely extend for it. And then we'll go with it from there, basically. Yeah, it's a mess, I can imagine. No, it's not. It's not to do with that. Yeah, it's not to do with the thread and doing the ray trace. There's sync points between the shaders. But yeah, Um, right, so we need to do this again up here. Damn it. Also, thank you. Thank you for your help. Really appreciate it. It's just a very, very strange thing. Rightio. Things. What? What? Oh wait, Atomic Store U32s. Right. What? 2 seconds. Eh. Eh. Alright, we're back. So, BVH in. Look at that. Oh, doesn't she look good? So, we still have to debug this in a way, right? We're looking at it and it's like, this thing looks fine. Why don't we just ray trace against it and just call it day? Well, we should have ways to basically view each level of this, right? Because we have these levels. Right. We want to just be able to debug and just see this tier. Right. I want to debug and just see these nodes, right? And then we might also want to manually see an actual node. Am I going to be doing bouncing light? I'm not sure yet. That's going to be part of the graphics R&D. It also depends how it works with rendering a bunch of spheres, you know? Because spheres, their normal is you know, it just, so it depends how big the spheres are and everything. I'm not sure. And the problem with the bounce light, it just makes it rough, doesn't it? And then you probably want to use like temporal stuff and I don't know yet. But we'll probably be exploring that sort of stuff soon. We're definitely gonna do some lighting soon. That's for sure. Ray trace shadows, quite possibly yes. Wait. Right. Possible. Yeah, I think I'll have an option for shadow maps so it's quicker, but then potentially ray trace shadows as well. Yeah, I think I'm gonna have like basically a a slower path and a faster path. Sorry, yeah, path for slow hardware and a path for faster hardware, that sort of thing. Right. So we basically in the BVH viewer, we want a way to just say, is it at this level? Render it, right? So we want to have like a debug option where we can just say, hey, can I debug view level? So this is fine because it's kind of a debug shader, but sometimes you want to compile some of these things out, right? In like release builds or something. Yeah, debug view level, right? And there's probably another one where you say debug view. What's the other one? Debug view node ID, we'll call it. So it'll be 1 plus an ID or something like that. So these, we'll set these up. They should be pretty easy to implement. Damn it. Oh, I didn't commit it, did I? That's a good point. We should probably commit it. A very good point. I did say I was going to commit it, didn't I? Let's do that. Hey Kappa, how's it going? How you been? So here we've added a BVH viewer. Wait. No. I don't know what I've done. That's a good question. It's been like over a week since my brain's... Right, so we've done the BVH viewer before, but this is the BVH construction. BVH GPU construction. Right. Let's just put these back. So 0 means they're disabled and we can change them. What we should really have is some custom UI, which we do have right as a UI renderer. So we should really have some panels we can pop up and just like enable this, disable this, right? But yeah, so they're in there now. So let's just program them in pretty quick. So literally we should just be able to say, right, so this bit here is when it says it's the closest hit and says you've hit this BVH thing, right? So you should say is allowed. So is allowed would basically mean if BC debug level equals 0, or this is equal to the current level. Right? And then you want to AND that with debug view node ID if that's equal to 0, or the node ID is equal to, so where's my node index? This is left, isn't it? So it's BVH. See, the node index could never be 0 anyway. Think about it, so it could probably just be an index. Thinking about it. You're never viewing the 0, 1. Or if it's equal to BVH left node. Or left index, right? So that will say if allowed, if we're allowed, go full ham and say we're the closest. So we basically just want to do that, but for the right hand side down here. So it's got to replace left with right. Cool. Job should be a good one. Yeah, the root is 0. We never render the root node. We literally we skip it. We start on 1, so we skip the root node because you're probably going to hit it anyway. So yeah, don't bother with that one. Yeah. Yeah, it also works out flicker as well, I guess, yeah. Well, the flickering was kind of introduced because of the BVH construction. The viewer was mostly fine. There's a few other little fixes. Okay, so my function, I allocate an allocator. My function goes out of scope, the memory deallocates, but allocate here. Oh, is this your C++ thing? I forgot, I didn't read that. But yeah, how's it going, Kappa? How you been? Have you seen this? Look how lit this is. Hopefully it doesn't crash the stream when I say this, right? But look, it's lit. We got BVH now, made on the GPU. So we're going to debug it and see. So really we should have a bit of UI which allows us to drag some sliders. We do have the ability to do that probably quite easily. But let's just do this, right? Instead, for now. Right, so here's the first level, right? We should probably stop it moving, even though I do kind of like it moving. Does look pretty cool. Set the time to 0. Yeah, so you're seeing your sort of BVH here. They can be inside of each other if it makes... Yeah, that's fine. Not best though. We're probably, the way we're constructing it, it could probably be constructed better, so we should really analyze this and sort of see what it's like. So what I think we should do is hook up the UI. So the UI should technically be rendered on top. So if I were to move the UI render, underneath, what does that do? Let's find out. Right, we should actually put some UI on the screen. Go to the main file, we should have some... should have some UI. This is our test scene that we had. Okay, so we're seeing our UI, right? Isn't she lovely? So, let's do a simple UI. Let's just put a button on the screen and just hope that it works, right? So we'll go to the top. So much debug stuff in here. Right, let's just draw some UI. Let's just do a text button. Also, no, keep it up. Soon you have your own animation suite. Still licenses of game does. Nah. Where's the fun in that? It would probably just be a custom animation thing, but yeah. Yeah, maybe you can bring back an age of, yes, it just works. Yes, I was able to reorder it. So I was worried that the alpha blending wouldn't work, but it has. Right, so we can just put things up here and just drag some sliders and just see it all. Be amazing. Yeah, maybe we can bring back the idea of custom engines and stuff. Like smaller engines that just do specific things, you know. Maybe. Yeah, you can sell a license of the engine and people can use it. So we basically just want to set these two things, right? Let's just make a quick debug UI. Obviously, it could be done way better, but for now, this is all we need. So we'll just, you know, start them off at 0, make them static so they persist. And we have these lovely, lovely, lovely sliders. Right. So we can literally say, oh, slider. So technically, so we have 206 of these guys. Actually, doesn't matter. I need to know the max. I know I kind of am actually, aren't I? That's a good point. Good point. We don't care about the explicit ID. So value mute, so debug level start is 0 and let's just say 206 because we know it's that. It could go over, it doesn't matter, won't cause any problems. Then the address of box style. Right. So we repeat that. Did the node go? Boom. Wait, 206? Yeah, it's not that many for. So it's log 2 206. That'll just be 8, wouldn't it? Maybe 7. Something like that. Right. So we should, with this, just be able to plug the bugger in and be able to basically just view the whole tree, scan it, and just see what it looks like. Right. Be right back. I just need to quickly check something. Alright, welcome back everybody. So we've just wired in some debug options. So fingers crossed we can just tweak this and see our BVH. Wait, we didn't cut correctly on the UIs. Keep cutting the rectangle. Your uncle, there we go. Oh yeah. So give that a run. Okay, so we've got 2 sliders, right? What are they? Well, you can drag this one and you can see the levels. Look at that. Oh. Looking a bit weird though on the edge there, tell you that. But anyway. Yeah, something's fishy going on. Definitely something a bit fishy. I'm not sure what it is exactly, but we're not seeing... Yeah, anyway, we'll have a bit of a play. So you put it back to 0 and it displays them all. But you can also just display an individual box, right? But some of them are... So this is going to be very useful. See, oh, the controls, man. I feel like I'm flying a camera, but actually flying the ship. It's just getting used to it. Alright. Yeah, some of these are not... Okay, yeah, so they only render... I thought they drew over the balls anyway. There's something fishy where it's not rendering... There's like a... It's like a... What? Right. I think the pixel. I'm not sure what's up that, but should have a bit of a. And also, where is that one? Why is it colored blue? It should be, yeah, that one is this guy here, but then it doesn't render the whole thing. Ah, that's probably because it collided with another box. Something like this. Right, that's a good idea. Render the spheres inside the box, that's a good idea. So I can't do that just yet, but if we because we're ray tracing this, yeah, we'd have to put it into the sphere ray tracer. Like, we're not traversing the BVH yet when we ray trace the spheres, but we could do it. We've got to traverse the BV. We don't have to traverse the BVH either. We could check the sphere and see if it's inside the leaf node. Oh no, we can't. No, we'd have to do a full proper traversal because we're selecting parents here and not leaf nodes. So you'd have to, yeah, it's a bit dodge. But yeah, we should be able to do that soon though, when we switch over to it properly. I just want to debug it the best I can before we switch over, because as soon as we switch over to this, it yeah, I want it to be as stable as possible. So before I switch over to it, basically. But it's looking all right. It's just when it's debug viewing, it's kind of off, which is weird. So that's the left node, that's the right node. Ah, this one had the problem, but it doesn't anymore. Oh, what is that? We'll investigate that. Hey, Remarch, how you doing? Yeah, but the edges, we need to see the edges, man. I have to see the edges. So it's only to do with when we had added this system, right? Closest depth hit. So we only write a pixel if there is a hit. And it doesn't even check the depth buffer of the main. We don't have a depth buffer, right? Of the main scene. We're just drawing on top. So we're allowed, if you hit me, equals level. That makes sense, doesn't it? But it's not always T min element. Is that right? Because you might have hit T max. Yes, you might have hit T max, basically. So which one did you hit? So you want to know which one hit. So imagine we can say this is like F32 hit depth, right? If that is true, then we want to be using T min, right? Else we do another test. If this is true, then it's T max element. If it's false, it would just be infinity. Yeah, if it's less than, good. So we just do infinity. Then we do another else. Wait a minute. That's all we need, isn't it? So about that. Bob's your uncle. So we should just have to check. I'm not sure if this is definitely a problem, but I'm not sure if it's the problem that we're encountering. But let's try that out. Okay. So we run over this. Still got the same problem. So I can imagine it's casting a ray. It hits one of this box. So it must hit this box. Hmm. The team in still buggered a bit. Hit depth. Is it possible that the colors are added and they cancel into black? No, the color doesn't get added because we just take note of which one it hit and then it calculates the color at the end. So let's try that out. Still the same problem. So you trace your array, you hit this box. Are you tracing and hitting any children boxes? But then the child boxes shouldn't report. Like these are the back ones, right? That it's failing with. And maybe some of the front ones as well. But we shouldn't be overwriting anything. So I wonder. Right, what does that team? Where does that team min go to? Right, it might not travel down. Might not travel down the right hand side nodes. If the team min, it's a bit of an optimization. Should we skip this optimization and see what happens? It should be able to traverse. Like we basically keep note of the right hand side that we hit earlier, but we are going to go down the left hand side because we hit the left first. And we did a bit of a check here to say, well, wait a minute. Yeah, we do a check to say, and basically say if the right hand side node is actually further away than our closest hit, just don't bother checking it. This could be it. So it's an optimization. But it could be the problem. No, it's not the problem. Damn it. But let's see if it is an issue though. Closest hit depth, T min. If you're closer. Yeah, that's fine. Never that easy. And like when you see it here as well, it's not actually being rendered anymore. There's another box on top of it, right? So there's another child box which matches the exact regions, right? In some way. So yeah, it's a little bit weird. Something to think about. But yeah, basically what we're going to be doing now is just debugging and making sure all of like everything is assigned correctly. You know, maybe we sort the way it's sort of allocating these boxes and making sure they're all fine. You know, if there's a way that we could probably optimize it somehow by changing our the way we make this on the GPU. And then when we have that, we're going to just ray trace against it. And hopefully it's faster than our current solution. Hopefully. TM. Anything behind the child box? I don't think there is. But yeah, something to think about. Right, I need to get going because I need to actually push these changes up, go over to my Windows build, rebuild the new compiler, and get the Windows build up as well. So it's going to take some time, and I also need to go to bed. So, right, just find something to read. But yeah, if you guys want to get access to the code and play it on your PC, you can visit there. And if you're a Twitch subscriber or a Ko-Fi supporter, you can access the code. Just follow that link there. Other than that, I have a Twitter where I probably should start posting now that I've got stuff visually happening again. But yeah, I'll next be on Tuesday, 6:30 p.m. GMT. Thank you so much for coming, guys. Really cool. We actually managed to fix the flickering problem, which was seeming like a bugger at first. Was going all into SpearV and the oh my days. Oh my days, crazy, crazy. You know. All right. Thanks, guys. Have a good night yourself. Have a good start to that work week, you know. And I'll see you all Tuesday. Right. Catch you later. Bye.